Hello, everybody. Welcome in. We're going to go ahead and let folks start filtering into the Zoom room here. As people join us, I would love to hear from you. Please hop to the chat box at the bottom of your Zoom window and just let us know whether you've joined us for a webinar before. I love to kind of see who's new, who's returning. We'll also be using that chat box as the way you can ask us questions. So get comfortable with it. Oh, Anne, nice to see you again. Welcome back. Dana, very nice. Thank you for joining us. All right, very cool. So it looks like we have some new folks, some returning folks. That's awesome. Well, you are in for a treat. Nüs and Melissa are excellent presenters and are going to dive into a lot of really good chemistry information for you. It looks like people are still joining us, but in an effort to make the most of our time, I'll go ahead and dive into my spiel so we can get to the science of it all. The most important thing for you to know is that we will be sending out a recording of this webinar. It typically takes about 3 to 5 business days to get that webinar edited and posted to our YouTube channel and website. But as soon as that is live in both of those places, I will also send you an email with a link to that recording. So keep an eye on your inbox. That is coming your way. And then besides that, please use that chat box at the bottom of the Zoom window to ask questions. We will be keeping an eye on that. So if you have any questions, do let us know and we'll make sure that we get that answered or follow up with you after the webinar. With all of that being said, I will pass you off to our fabulous presenters and I hope you enjoy the webinar. Thank you again for joining us.
Thanks for setting us up there, Dylan. Yeah, hi folks, this is Nüs Hisim. One thing that I really encourage you to do is if you have a second device, put graphical analysis on it. If you're on a computer or Chromebook, you have a separate computer or Chromebook, you can even run it through the web browser just by typing graphicalanalysis.app in the URL, but it needs to be a Chrome browser or that style browser. But yeah, if you want to follow along and get the data and get the full benefit of this professional development, by all means, stick it on another device so that you can get the data with us while we collect it. So the plan here is that we are going to give you a little preview of an experiment from the new forensic book that's coming up. So that's kind of the plan, and also a little bit of a reverse titration activity. But let's talk a little about ourselves here. My name is Nüs Hisim. I taught chemistry and physics in Maryland for 34 years, and nearly the whole time I used Vernier equipment. I've known David since 1984. When I came to Vernier in 2016, they made me a chemistry education specialist, since I used most of the experiments that were in our lab manuals, but also here to answer the phones, emails, chat, write curriculum. I've had a lot of fun. We put together a food book a few years ago, and now we're right at the end of putting together a forensic chemistry experiments book. And then I do a lot of training. Melissa, did you want to say a little bit about yourself?
Yeah, sure. Hi, everyone. I'm Melissa Hill. I'm also one of the chemists here at Vernier. I've been at the company a while now, I don't know, 13, 14 years, something like that. And I also help with all the curriculum and software and trainings, and I also focus a lot on product development. So I will be here to help keep Nüs on schedule and answer any of the questions that you have. So please put your questions in chat, and we will answer them as we go. And I'll be interrupting Nüs to make sure we get all your questions answered. So any question that comes up, please throw it in chat and we'll handle it.
Absolutely. Yeah. Like folks, I taught for 34 years. I don't mind being interrupted. Just bang it in there and we'll try to get it answered for you. And if we can't do it today, then we will certainly get back to you once we can get it. The activity, let me back up a bit here. The activity is one, when I was writing this book, I was trying to find things that you could use in your chemistry classroom that, concepts that you're going to teach, but maybe put a little twist on them a little bit. And this one, has a little bit of a twist. You can see from the sample graph here, we're going to create this ourselves in a minute anyway, that it's going to start high, which is kind of unusual. Most of the time when you do starting out with titrations, you're going to start with, you're going to titrate an unknown acid with a known base. Those two experiments from our advanced chemistry book are absolutely my favorite for teaching that, because the students learn how to standardize their base and then use that to find the concentration of an acid. But this one's gonna take that and go to another level. Let me bring you up the scenario. So every one of these experiments has a little bit of a scenario, and here's the scenario for this one. So, it says a Saturday's premiere of the play Grease proves to be an outstanding entertainment event. Star of the show, Elise Williams, delivers a stellar performance as Sandy Olson, the new girl at Rydell High, with her superb acting skills and euphonious voice. Williams' portrayal of Sandy makes everyone in the audience feel as if they were a pink lady or a T-bird. The same cannot be said for the co-star Laura Miles, who plays the part of the pink lady leader Betty Rizzo. Miles' lack of energy makes the exuberant character of Rizzo appear flat and uninteresting. Her subpar singing skills are obvious in her lackluster rendition of There Are Worse Things I Could Do. The song, stage settings, props, costumes all come together for an evening of songs and storytelling, all around magic. Acorn Acting Studios production of Grease is a runaway success, except maybe Laura's performance. And there's some texting going on between Elise and a friend, I guess. And so there's Elise, and she was taking her makeup off, and she got this rash, and it got pretty severe. Police were called, and you read the little bit of the scenario and the experiment. The detectives want to know. Someone suspects that sodium hydroxide was added to the makeup remover, and so your job is to determine the mass of sodium hydroxide that was placed in the makeup remover. And it's like very common sort of thing that we would probably expect our students to be able to do, and at least in calculations, and maybe even in a lab, an experiment. So I thought it would be kind of fun to take that and make it something that was very entertaining. I don't know about entertaining, but certainly exciting for students. So I've got my evidence here, and we're going to treat it just like you might do in your classroom. I used chain of custody forms and all that. One thing you might do if you are going to run graphical analysis and along with me, open up your copy of graphical analysis, and right here where it says additional features, put in that code. Melissa might tap it into the chat box so that you guys can get to it. And that'll give you access to Graphical Analysis Pro through the end of September. You can use that with your students. So by all means, try it, see what you think of it. There's lots of features. We're going to use the data sharing feature today, but there's a whole lot more in GA Pro. So the plan here is that, and you have to kind of set this up a little bit for your students, that the makeup remover, if you look at the teacher page, and I did share with you all the files you need to teach this concept. So in the this folder that you can get access to, let's see, we can drop it into the chat, or we can send it to you later or whatever. But in this folder, there's all the files you need, including the teacher page. And so that will show you how to make the unknown, because you want to make the unknown something that that's kind of somewhat realistic. I stuck with 2 molar. I mean, be careful, if you want to extend, if you want to, use a higher concentration, you can. But if you read the pre-lab, it says that the concentration is suspected to be around 2 molar. You might have to edit that. All of our experiments, when you get them from us, come in Word format and PDF. So if you want to adjust the scenario or you know what the instructions to the students, then by all means, you know, we want you to do that. That's why we provide the files in that format. So what we're going to do, the students in the pre-lab, they have to dilute this to something that's a little more safe to use. And also I wanted them to have practice, you know, with M1V1, M2V2. So you know, we're gonna do that right now. So you tell them that it's around 2 molar. I made this, I believe, 2.1 molar or something like that. They have to then, you know, make 100 milliliters of solution, right? So let's go ahead and get out the evidence. We are in the crime lab, and so we have to maintain a chain of custody. And I did put the sample of this in the shared folder so you all can get to it. So you know what? I didn't check it back in yesterday. Oh, that was my fault. So I'm going to go down here. Today is the 9th, and this is received by N Hisim 007, and I'm going to do a webinar. So, you know, I did have my students go through the whole process. It's a little hokey, but you know, the kids didn't think that. At least, you know, they kind of got into it a little bit. So let me get that out of the way. So here is my makeup remover, and you know, through the pre-lab, they have to dilute this and make 100 milliliters of solution, determine that if this is 2 molar, you know, how do I end up with a 0.1 molar solution, because that's going to be my known acid that I'm going to use. So what we're going to do is we're going to take 5 milliliters of the concentrated contaminated crime scene, and we're going to dilute that. Let's get 5 milliliters. Your call how you do this. I mean, I wrote it with, you know, pipettes, thinking, you know, that would be kind of neat to do it that way. Graduated cylinders are certainly doable. Okay. Get this out of the way so I don't knock it over, because that could very well happen. All right, let's top him up. And ruined that, didn't I? I was going to use this beaker as like my stirring beaker. And I went and put some sodium hydroxide in there. So let's clean that out. So there is my diluted sample ready to test. And of course, this adds a little level of complexity to the analysis later on. If you look at the experiment, it talks about, you know, the volume of the original contaminated makeup remover, and you know, so they have to keep track of all that stuff when they're actually doing the experiment. So what we're going to do is we are going to use a drop counter. We're going to use a pH probe. I'm going to do some live data sharing with you all, and then we'll do some calculated columns. I'd like to do the calculated columns with you so that you can get the experience of that. And that's why if you can set up the data sharing, as long as you have GA Pro going, the data sharing is coming in a minute. And then, you know, there's this thing about session preferences. We'll talk about that at the end, provided that we have time. So let's experiment. So I've got my diluted sample ready to go as per the pre-lab. And so that's ready. And so what we need to do is we're going to connect the sensors, set the experiment up, and then run the experiment. And that's at the point where I'll share with you all. And so let's connect the sensors. So on graphical analysis, right now you're just watching your, you know, there's not too much for you to do other than watch, but there will be in a minute. So what I'm going to do is I'm going to connect the pH probe and the drop counter. So I'm tapping the power button on each, and you'll see a red LED start to flash. That indicates that it's transmitting Bluetooth data, or at least connections. The pH probe is M7, so I'm going to put that in the filter box here, not M10, MT, M7. There we go. And I'll connect to the pH probe. And then we'll do the same thing with the drop counter. The drop counter, the last 2 digits are S3. So let's put that in the filter box here. You can connect these either way. You can connect them by Bluetooth. You can also plug them in by USB. All of them come with this USB cable. Everyone comes with one, and it serves 2 purposes. You can use it to connect, and you can also use it to charge the battery if you're gonna be you do it connecting by Bluetooth. There's a radio in there, and that needs to be charged. So that's kind of an important thing. The other thing that we get lots of discussion about is, do you need to calibrate your pH probe? And it depends. I mean, more often than not, you don't. For a titration, believe it or not, you're looking for the equivalence point. You're not really too worried about the pH, unless you're doing a Ka of a weak acid or something like that. And so, as long as it's close. So what I tell customers, and let me turn the meters on here. These little itty bitty meters at the bottom, I have a hard time seeing them. So I like to just turn on the big meters, and that way we can see what's going on. And so, the pH probe, let's go ahead and test that. Now, what I'm going to do is I'm going to take the storage solution bottle off the end. This is not water, folks. This is a pH 4 buffer with some potassium chloride and a mold inhibitor. We sell it. We also give you instructions on how to make it yourself. Little pro tip. I used to keep a container of nickels in my demo table at school. Didn't worry too much about my students stealing my nickels. But a nickel is perfect to put on the opening on a storage bottle. And that way, when your students, did you hear me? I said when your students knock that bottle over, you don't lose your storage solution. Okay, so keep some nickels handy. It's a nice little solution. All right, let's check. How good is my pH probe? So I'm going to go ahead and take a pH 4 buffer. And let's test it and see how good it is. Give it a little, I tell customers, give it a little swish and quit fooling around with it. Yeah, because it'll jump around all over the place. That doesn't look too bad, right? So that's good enough for now. You can calibrate these, of course. People ask, can you calibrate the probes? Of course you can. And you can store the calibrations on the memory of the probe, so you don't have to recalibrate them every single time you use them. But it depends. I mean, maybe you're teaching your students how to calibrate, then yeah, you can do a 1-point calibration. You can do it you can do a 2-point and a 3-point. Then yeah, I think you can do 1 point even with the Go Direct sensors. This is a pH 10 buffer. And once again, it's pretty good. So for the sake of our time, I'm not going to calibrate the sensors, but if you need help with that, we've got it on our website. We're happy to walk you through it. You basically, in graphical analysis, you tap on the meter and a little thing pops up and says calibrate, and then it walks you through how to do it. So it's not too much of a mystery how to do it. Now, let's talk about the drop counter. The drop counter does need to be calibrated in one way or another every time you use it. So the drop counter is really one of our dumbest sensors. It just has an infrared light detector in here. And when drops or your finger or anything fall through, you can see I put my finger through there and the red light is flashing saying, hey, something went through there. And so the drop counter is going to require that you tell it what the size of a drop is. Our system here uses a plastic tip, and these are not by any means like super precise. So, they're going to be off a little bit, and you're going to need to calibrate it at least once. And so if you tap on the meter and go to calibrate, it walks you through the calibration. It's a very nice system, but once you've calibrated it, you don't have to do it again. If you look on my drop counter, you'll see up here in the reservoir, it says 21.68 drops per milliliter. So once you've calibrated this and you have that information, you can then go into the manual tab and you can type that in, and you don't have to keep recalibrating it every time. The drop counters do not have built-in memory to store calibrations like many of the other sensors do. So this is important because, like I said a few minutes ago, when you're doing a titration, more often than not, it's the volume of the equivalence point that you're interested in. The only other time that you would care about the pH really is if you were doing a half titration to find the Ka or the pKa of a weak acid or a weak base. So I just put that value in. So basically my drop counter is now calibrated. So it's ready to go. So now what I need to do is fill it up, and we get lots of customers. I had a customer yesterday. Why are there two valves? One valve is the on-off switch. The other valve controls the rate at which the drops come through. So this experiment, we are going to titrate a base with a known concentration acid. So the acid is going to go in the reservoir up here at the top. Okay, so I have a known 0.1 molar HCl, and I'm going to put a waste container under here, and I'm going to fill the reservoir all the way up with the known acid. So you would have to provide this for your students unless you did something where you like experiments 6 and 7 in advanced chemistry, where you actually do find the concentration of an unknown acid. So the bottom is the on-off switch. I'm going to leave it off. Well, temporary right now, I'm going to turn it off. Okay. And the top one is the rate. So what I'm going to do is I'm going to let that go until I can get a drop rate of about 1 per second. For the sake of this webinar, I'm going to go ahead and speed that up a bit, just because we have a limited amount of time. I really want to get to the analysis at the end and walk everybody through it. So I'm fiddling until I can get a rate of about 1 or 2 per second at the most. pH probe is a slow sensor. You don't want to have if you have the titrant coming in there too fast, the sensor never has a chance to react. So that's a little fast, but I'm going to call it good for today. And I'm going to close the bottom valve. So now the drop counter setup is pretty close to ready. Now we need to get the sample ready. So what we're going to do is you can kind of see, we're going to put the pH probe in here, and there's going to be the sample, but we're going to need to dilute it. In the experiment, if you're using this size beaker, I said use 40 milliliters of distilled water. That is not critical. And boy, will this cause some consternation in your students. It's like, what? It doesn't make any difference how much water I put in here? So, start talking about moles and mole ratios, all those kind of fun things, right? And so now what I'm going to do is I'm going to take my diluted evidence, and I'm going to, one thing I should do is, because I only have the one pipette here, let me rinse this a little bit. And so I'm going to rinse it with the solution. Better probably to clean it, and because it has the evidence in there. I'm going to go ahead and waste 5 milliliters here for the sake of having a pretty clean sample. There we go. All right. So 5 milliliters of this goes into the beaker. We use beakers, not flasks, because the top is larger, makes it a little easier to hit the spot. With flasks, it's a little hard to hit the spot. So there's the 5 milliliters of basic diluted crime scene evidence. So now what you need to do is you need to do a little adjusting here, right? We're going to have to get the pH probe down into the liquid. We're going to have to adjust it so that the let me turn it this way for a moment, so that the pH probe doesn't get hit by the stir. And if you don't have a stir, you can swish it around. I just find these stirrers are super. We took us a long time at my school to save up to buy these, but they're so nice. I made them for a while by hand, and they were okay, but the Vernier ones, they're just so much nicer. Back in the day, I used to make my own magnetic stirrers out of motors and stuff, and it was okay, but not nearly as elegant as the Vernier one. Let me turn this a little sideways so you guys can get a better view of what's happening, because we're really close to being ready. And so what we're going to do is I'm going to share temporarily. I don't need this data table, so I'm going to get rid of it. We'll turn it back on later when we need it. So I'm going to share my data with you. So if you are have your copy of graphical analysis ready to go. What I need you to do is on your copy of graphical analysis, go to new experiment. And let me do it on my iPad. Unfortunately, my iPad won't project to my screen super well, but I can put it up here so you guys can see it. Start your copy of graphical analysis. And then once it's running, what I need you to do is I need you to tap where it says data sharing. Okay. And then it's asking you for a source. I'm going to give that to you right now. So if you've got Graphical Analysis Pro going, it has to be Pro for this to work. Then when you start data sharing, it will default to the online tab. And that's where you should be right now if you want to get data from me. I am the source of the data. So this could be the teacher, this could be one of the students in a lab group. I just tapped on this this TIE fighter icon in the top right corner, the sharing icon. And now I'm going to create a sharing session code, and I'll make it big enough so everybody can see it. Okay, so there's the code. And if Melissa, if you wouldn't mind putting that into the chat, YWH8ER. We went around with the software guys and we said, you know, these folks on devices like phones and tablets, they don't want big, complicated, you know, apostrophes and stuff like that. So we really got them to cut these codes down to where these sharing codes are actually pretty straightforward. And so you might notice, it's hard to tell on my iPad, but if you just did it, my iPad now says pH and volume. So, you know, it's kind of ready to collect the data. And so get that in there. And if you need help, tag Melissa and she'll walk you through getting it connected. So what I'm going to do now is I'm going to go out of here and I'm going to start collecting data, and nothing is going to happen. And the reason for that is it's waiting on the drop counter. It's waiting for a drop to fall through. So very important that this all be aligned properly. And I'm going to turn on the on-off switch. And then what's happening is I'm going to turn it so you guys can see it. I'm going to get you want that stir rate to be pretty high. That's a really high drop rate. I thought I had that adjusted, but apparently I didn't. The probe will not respond fast enough if you get a high drop rate. You'll get a curve, but it won't be as good. So I apologize. It's a little higher than I would want, but I think for our purposes, understanding it all, it's still going to work. Let me turn it sideways so you guys can see what's happening. You can see the red light flashing as the drops fall through pH probe. And then if you have Pro running on your end with data sharing, you should be getting a graph. Anyone getting it? Let us know in chat if you're getting the data. I'd love to see if anybody at all, or if I'm wasting my time. It is kind of cool. Think about your classroom. Maybe, yay, thank you. Maybe what you're doing in your classroom is you're doing a demo for your students. Or here's another thought. You've got a classroom set of equipment, but you've got 3 kids in a lab group, right? So one student is the source of the data. The other 2 are getting the exact same copy of the data on their own devices. And graphical analysis runs on anything. So you can run this on your phone. You can run it on an iPad. You could run it on Chromebook, whatever. And, you know, so even if it's a bring your own device type classroom, it'll still work. Right, you'll still be able to do this. So it extends your reach of your equipment a lot, you know, and this is just one of the features of GA Pro. There's many more, but this ability, like I'm in kind of near Portland, Oregon. We're a little bit outside of Portland, Oregon. Grazina, you're New Mexico. Remind me, Grazina, it's New Mexico, isn't it? Or Arizona. I know it's down there somewhere. Yeah, there we go. Thanks, Grazina. And I've done this with teachers in Korea, you know, and so it's kind of cool that, you know, you could share this data in your classroom. You could share this data with Johnny at home with a broken leg, you know, who still can, you know, get the data. And so it's really kind of neat that it has this. This grew out of COVID, of course, because teachers were, I'd like my kids to do experiments, but they don't exactly have stuff at home, so this is kind of a, where this actually came from. But you think about the different ways you might be able to apply it. All we care about is that that S curve. I did it backwards in the book also because I don't know how many AP teachers are out there. If you go back 2-3 years, there was maybe it was 18. Now that I think about it, there was a titration where the pH started high, and I think we get into the habit of at least students might, of thinking, well, they're always going to look like that S curve, and no, they don't have to. I'm going to go ahead and stop. I'm going to stop the drop counter first, and then I'm going to stop data collection. So on your end, you probably see it saying collecting, and now I'm going to hit stop, and it's going to go back to the little word collecting at the top of the screen went away. So that's why I did this. Is I wrote it this way so that it would be a little bit different. Now, if you're teaching a first year course, this might not be the experiment that you do first. If you want the students to see a titration curve that looks like the one in the textbook, this is probably not the good experiment to do first. Maybe they learn the technique, and then what they do is they apply it to this this scenario or something like that. So we're basically done now. The issue is we need to analyze the data. Most important thing here is we need to know what the volume of the equivalence point is. That's what everybody wants. And so first thing I'm going to do is I am going to disconnect from you, because if I stay connected with you, everything I do is going to appear on your end. And I want you to be the student. I want you to try this. So, we have half an hour, so we got plenty of time. So what I'm going to do is to disconnect from you. I'm going to go back to that TIE fighter in the top right, and I'm going to stop sharing. If I don't do this, then all the analysis stuff I do, you'll get automatically, and you might want that, and your students might want that, but I don't want it for you. I want you to participate. So I'm going to hit stop sharing, and now I'm no longer connected to you, but you should have the data. Before we do the analysis, this would be the perfect time to maybe save the data. Top left corner, file menu, go to the save option. You never know. I always told my students, you're going to have something happen, and some sort of event, power failure, I don't know, and you could end up. So that's not a bad thing to do, is to save frequently. So I can think of 3 different ways, but probably more, that we could get the equivalence point. The fastest way: tap on your screen. I'm tapping on my screen. Okay, I'm going to turn this stir off because we don't need it anymore. And in fact, there's not much over here you guys need to see. So what I'm going to do is make my graphical analysis screen bigger, and it's probably going to look a little more like yours. So if you tap on the screen, the fastest way to find the equivalence point is to look for the largest change in pH. And the equivalence point is going to be kind of in the middle of that. And so that's one way to do it, is to sort of decide, the equivalence point must be kind of in between here somewhere. Hey, Noose, isn't there a better, I like rhetorical questions. Isn't there a better way to do this? Yeah, there is. Okay. I don't need the meters anymore. I'm going to turn them off. So I'm going to go to the top right, this view options menu, and I'm going to turn off the meters, but I am going to turn on the data table. Okay. Because we're going to do some calculated columns. And so you should do that too. Top right corner, tap on view options and turn on the data table. If it's not on already, turn that on. Okay. So we're going to do, so the inflection point is going to look really obvious when, well, I say inflection point, but that's also the equivalence point. When we take the first derivative. So, if your students are in pre-cal or cal, oh, wow, we're applying some calculus here. So open up the data table. Let me make it a little bigger here so you guys can see what I'm doing. And we get a lot of questions like, do I have to take this to Excel, or can you do calculations and graphical analysis? Absolutely, you can do both. But why? If it's all right here. In the data table, right next to where it says pH, there's 3 little dots. Tap on that. And we're going to do a calculated column. So I'm going to go down here to add calculated column. We'll title that column first derivative. No units for this. Notice that in here, there's lots of other things to take note of. They don't apply to us too much in this experiment, but if you're doing a experiment, Beer's law type sort of thing with a sports drink or whatever, you might need significant figures and scientific notation because those concentrations are very small. But down here, error bars. Anybody out there, an IB teacher? This is new to Graphical Analysis Pro, so just take note of that. I'm going to tap where it says Insert Expression, and we're doing the first derivative. And this, by the way, the first derivative and second derivative are free features. These are not pro features. So you can do this experiment that we're doing. You don't have to have pro to do it. The first and second derivative, all of these upper things here that are above custom expression, they're all free. So most of our experiments, if not all of them, you can do with the free version. And anyway, we're going to do first derivative. Want to be careful that it's doing y against x. If it wasn't, you could tap on the little drop down and change it. But that's the order we want to do things in. And then tap apply. Okay, and you go, well, that was very uninspiring news. Left side, pardon me, tap on the label and then choose first derivative. Now it will plot that. Okay, and now it becomes a little more obvious, right? If you look at this, I don't like these point protectors. They seem to just make the screen look really blah. So, but if you don't like them either, bottom left corner, there's the graph options menu. And if we go to edit graph options, we can turn those off and turn lines on. I think it looks a little bit better if you do it that way. Your call, but those big fat points, they just, I don't know, they don't look so great. And so now what you can do is say, okay, the equivalence point is right there. 6.135. Sometimes it's not an actual point of data. And so you'll bounce around, you'll still end up bouncing around it. And so if we take the second derivative of the pH data, it'll be much more obvious where the equivalence point is. So we know how to do that now. In the data table, right next to pH, tap the three dots and then do calculated column. Let's do a second derivative. Melissa, how's it going?
Doing good. Got some comments about the error bars, and the AP uses them a lot too. So
I'll turn them on.
yeah, I mean, I don't know how.
There's a
Yeah,
lot of points here. So
yeah, this isn't a great example for using the error bars, but for
yeah,
Boyle's law, Beer's law, I love the new error bar feature. It's really nice.
Yeah, in this one, it's going to be pretty messy. They're going to be too many points. Yeah. Now this is getting pretty busy too. Wouldn't it, once again, rhetorical question. Wouldn't it be nice if we could, make this a little cleaner? Top right corner where the view options are, let's turn on two graphs. There's also three graph option, but they get kind of skinny. So I'm going to turn on two graphs. And then what I'm going to do, top graph is going to be the original plot. So I'm going to turn off the derivatives. So the tap on the axis, the label axis label, and I'm going to turn off the derivatives. So there's the original data. Then we'll come down here and turn on the derivatives. The other thing you have to sometimes check is that the x-axis is labeled correctly. Depending on the data, sometimes it won't automatically label it. And so that's a little less busy. Of course, it went and defaulted back to the point protectors, so I'm going to turn those off. A little less busy. And so the purists out there are going to say, well, Deuce, the equivalence point is right where it crosses the x-axis. I really like to get that value exactly. And so there is a way, and let me show you that. And it's kind of your call. It's not going to be off by much from what we have here, but it'll be slightly off. I'm going to turn off the first derivative and just display the second derivative. So on the y-axis label, I'm going to turn off first and just have second display. And what our goal here is to find the exact point where it crosses the x-axis. I'm going to zoom in a little bit. Kind of makes it look bad, but it actually makes it easier to do the analysis. So I highlighted that section I want, and then I'm going to tap on this magnifying glass. And so this is that section zoomed in. I want this point right here, point where it's crossing the x-axis. If I highlight the linear part of the graph around that, as linear as you can make it, sometimes you're limited by the number of points you have. Okay, but I'm going to go ahead and go from here to here. Okay. And then what I'm going to do is apply a linear curve fit on that data. So you can see that with this later version of graphical analysis, a lot of these graph options that are in the bottom left now pop up when you highlight a piece of graph. So right here it says apply curve fit. Linear is the most common one, so it pops up automatically, although there are every other option under there. So let's go ahead and apply a linear curve fit there. And now that I've done that, it's a little hard to tell because the data is pretty linear. Look at that 4/9 correlation. Of course, I only had 3 points in there, so can't pat myself on the back too much. But now I can get that value a couple of ways. My students would have to plug in for y equals 0, the slope and the y-intercept, and solve for x, right? There is a cheater's way. I never showed it to my students, but the smart ones found it. If you go to the to the little graph options icon, bottom left, then turn on interpolate. There's a built-in interpolator calculator. And as long as you have a curve on the graph, it will go between the points. So, I can go and find that spot where as close as I can get to where y equals 0. And you can see it's ever so slightly. I think it was 6.135 when we did it before. And now it's like closer to 6.136. So if you're a real purist and you want your students to really get that spot, then that's the way to do it. So what do they do now? Well, if I gave you the handout, what the students have is they have the equivalence point for the diluted makeup remover. Now it's a bunch of paying attention to the process, right? Because what they did is they diluted this based on their pre-lab. And then they took that and made it into, they diluted, well, I should be pointing to both of these. They diluted it based on the pre-lab, and then they did a titration. So now they have to work backwards, and they have to figure out, well, what is the concentration of this diluted makeup remover? Then they have to go back and say, okay, well, what was the volume of the container that the makeup remover came from, so they can calculate the concentration of the sodium hydroxide. I mean, this is pretty common calculations, right? But now they're doing this in the guise of being an investigator. So all of a sudden, this benign chemistry, problem became a solve the crime problem. I used to tell my students, you are not the detective, you're not solving the crime, but and so then once they know the volume and the concentration, they can calculate the mass of sodium hydroxide that was added to the makeup remover. So that's the gist of the whole experiment. I hope that when you guys get around to titrating, maybe you think a little bit about trying this one. You've got it. It just a little bit different in the view of it, but the actual concept is the same. What I did in the book is I made a table of contents that is arranged by chemistry concept. And so then if you're teaching that concept, maybe this experiment if you're teaching acids and bases and titrations, this might be a fun one to do. The whole book is that way. We did at Chem Ed last week, we did poison wine, which was really a Beer's Law experiment. If you're an AP teacher, it's kind of similar to the copper concentration from brass. It's similar to that. Or you can stretch it out to sports drink. It's kind of similar to that. And so, just trying to add a little bit of context to it in the sense of, my students, it wasn't unusual for a student to say, Mr. Hisim, when am I ever going to use this in my life? And so, well, look, you might be in a lab where you have to analyze something for whatever reason, and CSI catches a lot of attention. So we're a little bit early. Is there any thoughts, questions, concerns? Can you do this with wired sensors? Yes, you can. So if you already own our stuff, you can go ahead and do that. What is the acid concentration? And Christina, I was being conservative, and I kept the contaminated sample at right around 2 molar. And it's in the teacher's guide. You'll see it in the teacher's guide. In the teacher's guide, it walks you through making a 2.1 molar solution. I didn't want to make it exactly 2. I wanted it to be a little bit of a mystery. The idea was that somebody came by and dumped a handful of sodium hydroxide into here. But you could use a higher concentration. I just feel uncomfortable depending on the level of the students. So, with a higher level class, wearing gloves and being careful, maybe a 3, 4, 5 molar solution would be okay. Any other thoughts? Melissa, is there anything I need to address?
So I guess a question came up. How do you differentiate this experiment from regular to honors to AP?
I didn't even attempt to do that. I mean, it's folks, I taught them all, right? I taught, we had a chemistry course. It was not ChemCom. We started with ChemCom, but that whole water lab just drove me crazy. So we wrote one. It was called, shoot, I can't think of it. It was for the kids that needed that 3rd credit to graduate from high school. And I did experiments, not at this level, but I did experiments, from Vernier, even with those kids. But one thing that you'll get is all of these experiments, when you buy the book, you'll get them in editable format. So you can decide, for your level students, what more hints or less hints you want to give. So but frankly, I did not, try to say, oh, this is an AP core level thing. A lot of Chem 1 teachers will teach titration. So, I think this would be an appropriate activity for Chem 1, and, take it further. But I didn't go any further than that.
Yeah, I think probably with a lot of the analysis too, because of how much math they have. So like Chem 1, you could just use like the tangent feature or examine along the titration and just talk about it kind of more reaction based, and then add more math as you increase.
Yeah, let me go back. Let me go down. I'm going through the experiment, the handout.
Yeah.
Here is what Melissa was talking about. Just do an estimate of the equivalence point, and all this other derivative stuff, you could delete that, just take it out for a lower level class, and that would be a good enough, maybe. Do you spoon of makeup? No. What I did, Rajiv, is I bought a bottle of makeup remover and dumped it out, put sodium hydroxide in it. so I wanted the bottle to say makeup remover, but frankly, it's not really makeup remover. I mean, it's a little bit of artistic license there. So what you might do is find someone who has a container that's almost empty. I have 3 daughters. I would have no trouble doing that. And then clean the container out and put your stuff in there. But no, I don't, no particular brand. Any other thoughts or questions? What do you think? What do you think of this experiment? It's really dangerous, right? To ask to be analyzed or evaluated. But do you think kids might get a kick out of an activity like this? I'm watching the chat to see. Looks interesting. Thanks, Rebecca. I appreciate the small pat. Yeah, we did NSTA. We did a couple experiments from the book, and they seem to be well received by people in the audience or in the group. And so I'm hoping that this will give your class a little bit of a kick. We're hoping to have this thing out by either late fall or in the catalog. But if you look on our webinars, we've already done various versions of some of the experiments. And so if you go to our website and you look at webinars on our website, I think I had it up here. Well, I guess not. Under educator training, under webinars, you can see a number of experiments that are related to the ones that are going to be in the book. Question: what unit topic would you include this in, for example? Yeah, it's a good question. Solutions was for me. This was where I was teaching solutions. But you've got some conversions going on. So, they're diehard Logger Pro. I love the diehard Logger Pro school. Yay. Folks, I stole the experiment instructions from Logger Pro and just modified them to work with graphical analysis. So there's no reason you'd have to modify it. If you talk nicely to me, so at a later time, I might be able to sneak something out to you. But yeah, you could do this in Logger Pro. Absolutely. By the way, no go direct sensors in Logger Pro. Okay, so don't get that in your head. But if you're going to use Chromebooks, go direct sensors work beautifully. So if you're switching to Chromebooks, there you go. Here's your titration experiment.
I have another question for you. Can we talk about? Can we talk?
Gave me a ride. Go ahead, Dylan.
Perfect. Can we talk about cleanup and some safety concerns that you might have doing this lab, I guess?
Well, yeah, oh, sure, absolutely. Let me get the camera back over here. So one thing you saw that I was wearing gloves. Part of it is for dramatic effect, but part of it is, it is a 2 molar solution of sodium hydroxide. So that's something to consider. In my classroom, I had a spill kit, handy whenever I needed it. And so the main thing, if you're a Flynn person, the main thing is you spill low concentration acids and bases. It's just a ton of water, right? It's just, you just need to rinse things with water. As far as the probes go, we should probably talk a little bit about that. The pH probe, when you are finished with it, what you want to do is rinse it real good. So give it a good rinse. And the one thing that is not fixable, folks, is that glass bulb at the end of the pH probe. So you need to be careful with that. If that breaks, your pH probe is now a Harry Potter wand. You can start casting spells. But the nice thing about the new versions, the Grow Direct versions, is you can separate the electrode from the amplifier and replace just the electrode. And that's around half the price of the whole probe. But as far as, cleaning up and so forth, rinse the probe, go back to your storage bottle. Don't forget you have a nickel in there. Don't try to jam that sucker in there with a nickel. And then there's multiple ways, but what you want to do is just barely put the cap on the bottle. Don't tighten it all the way. Then put the probe in so that the electrode is all the way in the storage solution, and then tighten it. When you're tightening this, you're making the opening a little bit smaller. So what you never, ever want to do is try to pull this out when the cap is tight, because you will damage the electrode at the very tip. Drop counter, 0 maintenance. Try not to get liquid on it, but other than that, there's not a whole lot of maintenance. Any other thoughts of issues that you guys can see? Disposal. This is sodium hydroxide and HCl, low concentrations, down the drain with a lot of water. That's what Flynn says to do. Okay. Any other thoughts? We are here for you. That's what Melissa and I do. 50% of our job is answering questions, whether it be on the phone or whether it be by email or by chat. Our website now has a chat feature. And so if you have any questions about this experiment or any other that's related to chemistry, Probably the most convenient way to contact us is by email, chemistry@vernier.com. That's going to come to the three of us. We have three in our chemistry group, but you're welcome to call. We can Zoom these days. So if you want a demo or something, we're happy to do that. Just let us know. Please don't spend 2 hours doing something. And then when you call, we go, oh, all you had to do was, I feel so bad when that happens. So let us know, let us help you. And then if you need help with, setting up an experiment or something, by all means, let us help you get it done so that you'll have a good experience. Dylan, you're going to talk about the recording, or did you already?
Yes, I can hop back in. We will have the recording up on our website as well as our YouTube here in about 3 to 5 business days. We just like to edit it out, make sure it looks good. And then as soon as that is ready to go, you can access that anytime on the website or YouTube, or we will email it to you. Anyone who registered will get an email with a link. So you will have access to that, and we're here to help. So if you don't see it, feel free to reach out. We'd be happy to send you a link. And yes, Nüs is showing you here where you can see all of our fabulous videos. So if you ever want to scroll through, see what we've done, it is a great resource. So
I noticed that Dylan popped a certificate in there too. Look at that.
that's right.
We used to get a little bit of credit in my district in Maryland for doing PD. So, there you go. If that helps you, by all means, it's in that shared folder of materials, and by all means, take advantage of that. All right, I think we've come to the end. Thanks, folks, for attending. Looked like we had a good number of folks here today, and if there's anything we can do to help, please don't hesitate to let us know. Okay.
Bye, everyone.
Bye.